Welcome to ChemZone chemistry classes. This is Umesh Thamija, chemistry expert. In this video, we are going to discuss about chemical properties of aldehyde and ketones. This video is very useful for all those students who are going to appear for medical and engineering entrance examination, and also for their board examination. If you have any doubt, you can send your doubt at my WhatsApp number given in the video itself. If you like this video, share it with your friends also. If you have not subscribed yet, subscribe this channel and don't forget to press the bell button. You will get notification for all the new upcoming videos. So let us start the class. Thank you. We have done?
Yes.
Okay. Yes, we have done it. So so we start today's topic as can you see my screen?
Yes, sir.
Right. So it is nucleophilic addition reactions.
Yes, sir.
With elimination of water. With elimination of water. This is a journal representation of the carbonyl compounds. It can be aldehyde or it can be ketone, right?
Yes, sir.
And now if we add here ammonia derivative means one H of ammonia is replaced by some other group Z,
Yes,
right? In the pH range of 2 to 3, so 3 to 4, right? Then we get here addition product with the loss of water molecule, right?
yes, sir.
First of all, I'll be discussing here what is this Z, right? This Z can be OH group. Then this product will be, reactant will be NH2OH. We call it as a hydroxylamine.
Yes,
We call this is a hydroxylamine. And the product formed here with the carbonyl compound, you can see here we are basically removing water from here. So it is a N and OH group will be there. This is called as an oxime,
yes, sir.
right? And if this Z is NH2, then it is NH2NH2. This is commonly called as a hydrazine, and it will form here C double bond N NH2, and this is called as a hydrazone, right?
Yes, sir.
It's an addition product, and it can be, this Z can be here NH2, and now it is an NH with a benzene ring. We call it a phenylhydrazine.
Yes,
When it undergoes addition, nucleophilic addition with this carbonyl compound, water is lost,
yes, sir.
and now it is a phenylhydrazone. Right?
Yes, sir.
and then it can be two 4 dinitrophenylhydrazine. This is a 2,4 sorry, dinitrophenylhydrazine.
Yes.
When it combines with carbonyl compound, it forms here 2,4 dinitrophenylhydrazone. Right? It is commonly called a 2,4 DNP. DNP stands for 2,4 dinitrophenylhydrazine. This is also called as a Brady's reagent.
Yes, sir.
So this will be now called as a 2,4 dinitrophenylhydrazone. Right?
Yes, sir.
And the other one is last one is semicarbazide, NH2 CO NH2. So this is the group here Z. When it this compound is called as a semicarbazide.
Yes, sir.
It forms here NHCO NH2. This is called as a semicarbazone. So you can see in place of ene we are putting here on, hydrazine, hydrazone, phenylhydrazine, phenylhydrazone, 2,4 dinitrophenylhydrazine, 2,4 dinitrophenylhydrazone, semicarbazide, semicarbazone, right?
Yes, sir.
Now I'll tell you why do we need a specific pH of 3 to 4. First of all, let us see the mechanism of the reaction. Then I'll be discussing here why this particular pH of 3 to 4 is required. This is a carbonyl compound,
Yes, sir.
and pH 3 to 4 means it is acidic in nature. So H positive attacks over here, and now you can find that this O will acquire a positive charge. On this positive charge, this compound G, that is ammonia derivative, will attack here as a nucleophile on the carbon atom, and this is the electromagnetic effect. You got this?
Yes, sir.
So it will form here OH, it will become neutral,
Yes, sir.
and it is a G here. Now the this become positive charge because nitrogen has lost one electron. Now the H goes this side, it forms here OH, this is a NH with a G,
Yes, sir.
right?
Yes, sir.
And this become positive charge. Oh wait, now this become positive, right?
Yes, sir.
Oxygen carrying positive charge is stable or unstable?
Unstable.
So it gains electron from the carbon, goes out as a neutral water. Now the carbon acquire positive charge,
Yes, sir.
and now H positive is lost, double bond is formed here. The catalyst was the acid here, it was added in the beginning, now it has gone out, and this is the ammonia derivative,
Yes, sir.
right? Sorry. Now question arises here, why do we need a particular pH of 3 to 4? If pH is less than the 3, then the H positive ion concentration will increase, because we know that pH is equal to negative logarithm of H positive ion, right?
Yes, sir.
If that increases, this ammonia derivative will combine with the H positive, and now you can see that on this ammonia derivative there is no any lone pair now. It means for this reaction the ammonia derivative must have a lone pair through which it can attack. It means at this low pH, nucleophilicity of ammonia derivative decreases. Is this clear?
Yes, sir.
And if pH is increased, if pH is greater than 4, in that case what will happen? The H positive ion concentration will decrease,
Yes, sir.
and with this what will happen? The first step of this reaction is, you can see that it is basically activating the carbonyl group, this step.
Yes, sir.
If the H positive ion concentration decreases, then this activation will not take place,
Yes, sir.
right? So the reactivity will decrease. So we can say the carbonyl group will not be activated.
Yes,
Or we can say its electrophilicity will decrease. Electrophilicity will decrease.
yes, sir.
Are you getting me?
Yes, sir.
Right. So we need a particular pH range, that is 3 to 4, otherwise reaction will not take place. Is this clear?
Yes, sir.
Now, now can you tell me the name, common name of this compound,
Formaldehyd.
and what is the IPC name?
Ethanol.
If you react here with the hydroxylamine in the acidic medium and having a pH of 3 to 4, 3 to 4, it can be 3.5 also,
Yes, sir.
then what will happen? Generally we say the water goes out
Yes, sir.
and we get here, this is the oxime.
Yes.
So this compound is called as a methanol. So this compound will be called as a methanol oxime.
Yes, sir.
If you have an ethanol, then we call it a ethanol oxime. If you have a ketone like propanone, then we say propanone oxime, right?
Yes, sir.
Similarly, if we have, this is the ethanol and reacting with the hydrazine, in the pH of 3 to 4, what is lost?
Yes, sir.
We call this is a ethanol hydrazone.
Yes, sir.
Ethanol hydrazone. Getting me?
Yes, sir.
This is a hydrazine. So it is a ethanol hydrazone. Are you getting me?
Yes, sir.
Similarly, if you have propanone, it will give you propanone hydrazone, right?
Yes, sir.
And if we have a combination with the phenyl hydrazone, water will be lost.
Yes, sir.
Now this will be called as a propanone phenyl hydrazone. Propanone phenyl hydrazone. This is a phenyl hydrazone, right?
Yes, sir.
So propanone phenyl hydrazone. Any doubt?
No, sir.
Now if we react this carbonyl compound with 2,4-DNP, 2,4-DNP stands for 2,4-dinitrophenylhydrazine.
Yes, sir.
Water will be lost.
Yes, sir.
And we get here 2,4-dinitrophenylhydrazone of ethanol. And this product formed is having either yellow or orange or red precipitate, depending upon the number of the carbon atom in the carbonyl compounds. And this is a conformity test of the carbonyl group.
Yes, sir.
Conformity test of carbonyl group. So you can use this test for the questions like distinction test. How will you distinguish between propanone and any other functional group? Let it be, it is a carboxylic acid, propanoic acid. So this DNP test is given by the carbonyl compound, that is a ketone or aldehyde, but not by any other functional group,
Yes, sir.
right? So this test can be used with to distinguish between the carbonyl compound and the non-carbonyl compounds.
Yes, sir.
Now question arises here, in case of semi-carbazide, if you see the mechanism, then the lone pair from this ammonia derivative attacks at the carbon atom of the carbonyl. Now my question here is, out of this 1, 2 and 3 nitrogen atoms, which will be involved in the reaction and will be acting like a nucleophile? 1, 2 or 3? Sorry. Why 2? Why not 1 or why not 3?
2 is closer to the carbonyl group.
See, if you see the mechanism carefully, then this is the carbonyl and it is first of all activated by the acid, right? It become positive charge, and now the ammonia derivative attacks through the lone pair, right?
Yes, sir.
In case of the first carbon atom, this lone pair is involved in the resonance. It means first cannot act like a nucleophile. In the second, this is also involved in resonance. This cannot act like a nucleophile. Electrons are not free to move, but this nitrogen lone pair are not involved in resonance. So the third nitrogen will act as a nucleophile, not the first or second. Are you getting me?
Yes, sir.
Right. So this is a very important question here. Why this particular nitrogen is involved? Why not 1 or 2? Any doubt till now?
No, sir.
No doubt. Okay. And now we discuss about the next type of reaction, that is called as a reduction reaction. Reduction of carbonyl compounds. Reduction of carbonyl compounds. What do you understand by the reduction?
Addition of hydrogen or the mole of oxygen.
Very good. So it's a aldehyde here,
Yes, sir.
and for the reduction we need some reducing agent.
Yes, sir.
For that I can use here hydrogen and a platinum or nickel, or I can use here lithium aluminum hydride as a reducing agent, or I can use here sodium boron hydride as a reducing agent. So it adds hydrogen here across the double bond, hydrogen is added and we get the primary alcohol. Means aldehyde upon reduction give primary alcohol. And if we have ketone with this hydrogen and a nickel or platinum, we can get here a secondary alcohol. Is that clear?
Yes.
And now I will be discussing about the importance of these reducing agents like lithium aluminum hydride or sodium boron hydride. These are very good reducing agents. Lithium aluminum hydride is a more powerful reducing agent as compared to the sodium boron hydride. As compared to sodium boron hydride, lithium aluminum hydride is more powerful reducing agent.
Yes, sir.
Reducing agent. Why it is so good powerful reducing agent? For that we can say it not only reduces the carbonyl compound aldehyde or ketones, but it also reduces the carboxylic acids. It also reduces the esters. It also reduces the amides.
Yes, sir.
Anhydrides, nitrile, oxymes, alkyl halide, right? All these are reduced along with this aldehyde or ketones, right?
Yes, sir.
So if I have a compound like this, you can see in this compound I have, this is the carbonyl compound and this is the ester compound, ester part of the molecule. If I am using here lithium aluminum hydride, it reduces the carbonyl compound as well as it reduces the ester also. It also reduces the ester. But in place of it, if I use here sodium boron hydride, then it will reduce a carbonyl compound, but it will not affect or it will not reduce the ester part. This way I say this is lithium aluminum hydride is a strong reducing agent as compared to the sodium boron hydride. Is this clear? And another important point is lithium aluminum hydride or sodium boron hydride, none of the two reduces isolated double bond. Isolated double bond. Like this, if I have double bond here,
Yes, sir.
and here I have an aldehyde, this double bond is not in conjugation, not in resonance with this carbonyl compound. If I use here lithium aluminum hydride or sodium boron hydride, right, that the double bond is not affected. The double bond is not affected by this. Only the aldehyde get reduced. Is this clear?
Yes.
So the double bond is not affected. But very important point. If we have alpha beta unsaturated aldehyde or ketones, if we have alpha beta unsaturated aldehyde or ketones, in that case, this lithium aluminum hydride reduces only the carbonyl compound, carbonyl group, but not this double bond.
Yes, sir.
But if I have a sodium boron hydride, it reduces both the carbonyl as well as carbon double bond, right,
Yes, sir.
as well as carbon double bond. Clear?
Yes, sir.
And I'll now give you one example here. What is the meaning of the alpha beta unsaturated aldehyde? This is the compound here. The functional group is the aldehyde here, and this is the alpha carbon atom here, this is the beta carbon atom here. In this compound, if I add here lithium aluminum hydride, then only the aldehyde group is affected, it get reduced, but double bond is not affected. But if I have a sodium boron hydride, it reduces the double bond as well as the carbonyl compound,
Yes, sir.
right? But only 40% happens like this, and 60%, in 60% cases, the double bond is not affected, right? Getting me?
Yes, sir.
But in this case, if I reduce it with hydrogen, it is one of the strongest reducing agent. It reduces the double bond as well as the aldehyde to the alcohol. Is this clear? Okay. And this is the ketone.
Yes.
These ketones are reduced by aluminum isopropoxide. Aluminum isopropoxide. See here, aluminum isopropoxide here. This is the O here. 3 times with the aluminum, right? Aluminum isopropoxide. It's a very good reducing agent. It reduces this ketones to the secondary alcohol, and this reaction is called as a Mirvin-Pondorf
Yes, sir.
Worley reduction. Mirvin-Pondorf Worley reduction.
Yes.
Is this clear?